Hello everyone, welcome back to our channel. Our topic today says waves. So if you look at the board, you will see that the definition of the wave is already on the board. A wave is a disturbance that moves, transfers energy from one point to another without imparting motion to the medium through which it propagates. We have some basic terms that we use in describing a wave. These terms are frequency, amplitude, period, wavelength, and wave speed. So we're going to be defining this term one by one. The basic terminologies. The first one is frequency, as in F. F is the symbol for frequency. We now have that the frequency is the number of cycles per second. That is the definition of the frequency. The SI unit of frequency is hertz, and the symbol for hertz is Hz. So according to the definition of the frequency, it means the number of cycle, number of complete oscillation in 1 second. That is, for example, in 1 second, if the complete oscillation is 3 or 2, that means the frequency of that cycle is 3. The second term is amplitude, as in A. A is the symbol for amplitude, and it says that the amplitude of vibration is the maximum distance of displacement of the vibrating particles from their position of rest. The third one is period, and the symbol for period is T. The period is the time taken to complete one cycle, and the SI unit is second or seconds. The fourth one is wavelength, and this is the symbol for wavelength. The wavelength is the distance between successive crests or successive trough, and the SI unit is in meters. So from this diagram, our wavelength is the distance between these two successive crests, or the distance between these two successive troughs. And the last one is wave speed. The symbol is V. The wave speed is defined as the distance covered by the wave per second. That is what the wave speed is. Now, let us look into relationship between frequency, velocity, and period. The relationship is that frequency F is equal to 1 over T, and T is the period. So frequency is equal to 1 over period. Then velocity is equal to product of frequency and wavelength. Or from here, you can say that our frequency is equal to velocity over wavelength, and T, which is the period, is equal to 1 over frequency. Let us take some examples from the relationship between frequency, velocity, and period. Here is the question. The question says a longitudinal wave of frequency 100 vibration per second has a wavelength of 11 meters. Find the speed of propagation. From the question, we have that our frequency is 100 vibrations, and our wavelength is 11 meters, and we are looking for velocity v. So we are looking for the speed, which is the velocity also, and the symbol is v. To find v, we're going to use this equation. V equal to product of frequency and wavelength. So frequency 11 multiplied by wavelength is going to give us this. So our speed, which is v, is 1100 meter per second. And that is our final answer. The second question says, if velocity of wave is 0.15 meter per second and the frequency is 20 hertz, what is the wavelength? To solve this, let me first of all write down the quantities and their values down. Having written the quantities down, we have that our velocity v is equal to 0.15 meter per second, frequency f is equal to 20 hertz, and wavelength is equal to what? So we are looking for wavelength in the question. We are going to be using the relationship between frequency, velocity, and period for this question. From v, the velocity, equals to product of frequency and wavelength. We now have that wavelength is equal to velocity over frequency. Wavelength equal to 0.15 divided by 20. We are going to have 0.0075 meters as our wavelength, or in standard form, we have that wavelength is equal to 7.5 times 10 raised to power minus 3 meters. And this is our answer. The next question says, which of these is correct? Option A, T, which is the period, is equal to 1 over frequency F. B, T is equal to F. That is, period is equal to frequency. And option C says frequency F is equal to 3 over 4T. So which of them is correct? The correct answer is A, that T, which is the period, is equal to 1 over frequency. So option A is correct. And you can see that from the relationship between frequency, velocity, and period. Let us move into progressive wave. Progressive wave. If you don't call it a progressive wave, you can call it a traveling wave. A progressive wave is a traveling wave which spreads out continuously from a source to another point. It is a traveling wave which spreads out continuously from a source to another point. Let's go into progressive wave equation. Progressive wave equation. This is the equation for progressive wave. Y is equal to a sine bracket 2 pi t over period plus or minus 2 pi phase difference over wavelength bracket close. We are going to be using this equation to solve some exercises on progressive wave. Our exercise number 1 says a plane progressive wave is represented by the equation y equal to 0.3 sine bracket 200 pi t minus 20 pi x over 18. Find I frequency, II wavelength, III speed. Now to start solving, I am going to write down the general progressive wave equation down. This is the general progressive wave equation. We are going to be comparing this equation to this one given in the question. Comparing these two equations, and we are looking for frequency. Our frequency falls here. So we are going to map out these two quantities together. I'm mapping it out and compare. Comparing, we have that 2 pi t all over period is equal to 200 pi t, and 2 pi of t is equal to 200 pi t. Divide both sides by 2 pi t. We now have f is equal to 100 Hz. So our frequency is 100 Hz. To look for wavelength, we compare the two equations again. And from the equation, we are comparing these two quantities. That is 2 pi x over wavelength is equal to 20 pi x over 18. The next thing to do is to cross multiply. When we cross multiply, let's see what we are going to have. Look at what we have. If we cross multiply it, we have that wavelength multiplied by 20 pi x is equal to 18 multiplied by 2 pi x here. So from here, we are going to multiply everything in the bracket out. So let's multiply. Wavelength times 20 pi x will give us 20 pi x wavelength equal to 18 multiplied by 2 pi x will give us 36 pi x. The next step is to divide both sides by 20 pi x. Twenty pi x wavelength divided by 20 pi x will give us wavelength. That is, we cancel this and cancel this, and we are left with wavelength. This is the wavelength. So 36 pi x divided by 20 pi x is going to give us 1.8 meters. So our wavelength is 1.8 meters. This is our wavelength, and that is our final answer. The next question is speed. Find speed. The speed v is equal to product of frequency and wavelength, and is equal to 100 because our frequency is 100. That is the calculated frequency, and the calculated wavelength is 1.8. When you multiply the two together, the two values together, we have that our speed v is equal to 180 meter per second. That is our final answer for speed. Thanks for watching. Please like, share and subscribe to our channel. See you next Wednesday.